Great. Okay. I'm sure some people will continue to join us just as we start. Thank you, everyone, for coming again. I imagine we're getting some of the same students today that we had yesterday for the computer science talk, brilliant talk we had from Sussex yesterday. Today it's Manchester that we're going to go and do a talk initially on software engineering. And we've got Suzanne Embury who's a lecturer on the software engineering course at Manchester. We also have Jez Lloyd with us, and Jez can tell us a bit more about the department as a whole. As you know, there are all these different avenues you can go down with computing and technology, so he can maybe just show you a bit more about that at Manchester. It's worth pointing out Manchester's the biggest university in the UK, and so they do have quite a lot of different pathways and ways into different areas. And we're also really lucky to have Joanna Cruz at the bottom there. You might be able to see in the picture. And she's a current student on the software engineering program. So she's going to give us a other dimension to what's going on. Okay. As always, please put any questions you had in the chat. I thought there were some fantastic questions yesterday, particularly regarding technology and things you wanted to know about the course. Again, things that I can't help you with, I can't answer, things that only academics and specialists in that area can do. So put some more of those in, and hopefully we'll have a good chat at the end. But I'm going to hand over to Susanna now, and she's going to tell you a bit about the software engineering course at Manchester. Thank you.
Great, thanks for the introduction. Well, it's great to be here talking to you today. You can't stop me talking about software engineering, so you might need to shut me up if I go on for too long. So what I'm going to do just now is a really very brief introduction to software engineering. It's a massive field. It's a whole discipline itself. You can do PhDs in software engineering, you do a whole degree in software engineering, and I've got about 15 minutes to cover it. So this is going to be necessarily quite quick, but we can maybe go into more details that interest you in the questions. So here are the, hang on, see if I can get my slides to change. There we go. Yeah, so this is who we are. As was introduced, I'm a reader in software engineering at the university, and I teach on the software engineering courses, but also at the moment I'm on a Royal Academy of Engineering Industrial Fellowship at a company called ARM, doing research with them. And Joanna is one of our computer science with industrial experience students, and at the moment she's on industrial placement at ARM. She'll tell you a little bit more about that later. And we've also got Jez Lloyd with us, who's our marketing and recruitment officer, and he's also the editor, producer and presenter of our CS at Manchester podcast. So if you're interested in any of the stuff we talk about today, you can look up our podcast and hear more about what we do. So I don't need to tell any of you that software is quite important to us today. It affects us in terms of healthcare, government, industry, every part of life, particularly when we go into lockdown because of global pandemics, it becomes especially important. But also software and the data that the software provides and manages is going to be really crucial to solving today's big problems. If we solve climate change, it's going to be in part because we use the data we have really well. And it's going to be the next generation of software engineers, those of you that choose to go on down this route, who help us to solve these big problems. But what is software engineering? Well, first of all, maybe I need to say what engineering is. And my favorite definition of engineering comes from Arthur Wellington, a 19th century railway engineer. And he described it as the art of doing that well with $1, which any bungler can do with 2. So what he's saying there is it's not necessarily that difficult to build some of the things we're building, but the challenge, the really hard thing, is to do them well. So the quality of what we build matters, and with $1 instead of 2. So the resources matter as well. And a really good software engineer will be able to do that with software. They'll be able to build really high quality software with the resources they need. So what we're talking about when we talk about software engineering, and to compare it with what you heard about yesterday, computer science, the big difference between software engineering and computer science is that in software engineering, we don't just care about what we're building and solving fancy, tricky technical problems. We care about the quality of what we deliver. And in particular, we're very, very concerned about actually delivering value to our clients and to our users. and building software that's genuinely useful to them. But we also have to deliver it on time. If your country is chosen to run the Olympic Games and you don't manage to deliver the software to support that until after the Games is over, that's pointless. You know, we're often working to really hard deadlines in order to deliver that value. And also the amount of resources we use matters as well. We need to deliver to budget with the amount of people we have and with the resources we have. But even beyond that, there's a longer term question, because we don't just build software and then the job is done. Software, a typical lifetime for a software system is 10 years. That's very typical. It's very, very common to have software that's much older than that. The oldest software I know of that's in currently active use is 30 years old. But many of our software systems, things like the Unix operating system, there will be lines of code in that date back much older than that, much longer than that. And software has to remain useful and easy to change over its lifetime. So it's no good just delivering the perfect system for now. We have to be able to change it and improve it for later. It turns out that this is much harder than it might seem, really, really hard. And there's some features of software engineering that make it different from traditional engineering. You'll have seen many headlines like this, I'm sure, but we have as a planet wasted many, well, billions, trillions of dollars on poor software. I've got a series of headlines for you here. I mean, in the UK, quite UK-centric headlines, but you can find the same in any country. We've lost many millions on attempts to deliver a national health service program for IT, and we continue to lose money on that. Here's where we were losing an IT legal case. So on top of all the money we'd lost spending trying to deliver and develop this software, we also lost money in legal cases with the developers. Here's another example, £4 million for an IT system that wasn't used, paid by the Home Office. So these two examples are both kind of governmenty and involve Fujitsu. I'm not having a go at Fujitsu here. It's just that my headlines happen to include them. It's the same across the board, really, with all these companies. Another example, another $1 billion lost to taxpayers with the failed software systems. It's just staggering the amount of money that we are wasting as a planet on failed software. So why is that? I mean, that's a little surprising, isn't it? Particularly if you think about how long we've had. The problem with developing software was recognized in 1968 when there was a conference organized by NASA to try and understand what was going wrong. At that time, the term software crisis was coined, because even then, people were realizing how much money we were wasting on software. And at that time, in 1968, at that conference, the term software engineering was coined. And at that point, we started to use more traditional software engineering methods. So throughout the 1970s and the 1980s, the big drive in software engineering was to try and bring ideas from bridge engineering, structural engineering, civil engineering, all the other traditional engineering disciplines who were doing much better than software engineering was doing, trying to bring them in and improve how we built software. It turned out they didn't work. So it turns out that software engineering is special in many ways. It's definitely engineering, but there's many features about it that are special and counterintuitive. One of the areas that I teach and research in is a type of software engineering called agile software engineering. Some of you may have heard of it. And that's the kind of software engineering that from the 1990s we've started to practice, and we've basically thrown out many of the traditional ideas about how we build software. I'm just going to give you one example of how we build software nowadays that's perhaps a little surprising and counterintuitive. So the traditional engineering methodology suggests that we should begin by gathering our requirements from the customers, and we write them all down. And when we've understood what the customer needs, then we can go about designing and building the product that meets those requirements. And then when we've built it, we should test it. And then we can deploy it and send it out to the customers. it turns out that this order is not right for software at all. We can't gather the requirements at the beginning. When we try and do that, we build the wrong system. Studies like the Standish Chaos Report, which is a study of the software engineering industry that comes out every year from the Standish Group, they indicate that about 30% of software projects are failures, completely fail, don't deliver anything useful. And those studies also indicate, it's not scientifically proven, but they suggest that about 60% of the software that we write, the features that we implement and the lines of code that we write are either never used or rarely used. So we're definitely doing something very, very wrong here. It's not a technical problem. It's not that we can't build the computer systems, that we can't solve the technical problems. The real challenge is that we don't know what we should build. We build the wrong thing and we don't build it in the right way. So it turns out that, in fact, instead of starting by gathering all the requirements, we should just gather a few requirements and then start to build straight away and start to deliver as fast as we can. There are new methodologies called things like lean startup, where the idea is to try and test out your ideas as fast as possible. So instead of spending 6 months or a year building a software system and then delivering it, instead, modern approaches, we try and deliver within 1 week or 2 weeks or 3 weeks from the start of the project. But we just deliver a little tiny piece of the project and we check that that works and we test it and we deploy it. And then we move on to the next part and gradually we grow the software system. So that's one complete change in how we build software. How we test software has completely changed as well. That's really revolutionized over the last 10, 15 years. It used to be that testing software was something that happened at the end of a project. Now, I don't know if any of you have ever had a project with a deadline and the project's run late. This is a very human thing, isn't it? That we think we can do a certain amount of work in the time we have, but we can't. We can only do a small part of that. When you put testing of software at the very end of the life cycle of the software and the project runs late, you end up not having time to test software. And that's really, really bad. There are many, many examples of software systems that have gone out to customers with no testing at all, just not tested because they've run out of time to do that. So we've learned our lesson now, and instead we move testing right to the very beginning. It can actually be using techniques like test-driven development and behavior-driven development. You can actually start testing right from day one of the project. And testing, which used to be a very technical topic, has now become something which is much more a collaborative thing that's done with the customer and with the client. And even deploying the software, that's something we try and do now from very early on. Even before we know what the customer wants, we would try and deliver and actually practice deploying on the customer's environment so that we can see the problems well before the deadline comes along. So that's just a little tiny taste of some of the things we do with software engineering. I'm afraid when I uploaded this picture, it made all the text very small. So apologies for the tiny, difficult to read text. I just wanted to say a couple of minutes on the kind of careers that you can do if you start with software engineering, if you focus on software engineering, and then I'll hand over to Joanna and she can tell you, she's currently working as a software engineer in industry and she can tell you a bit more about that. But there's perhaps a bigger diversity of range of careers in software engineering than you might have thought. You might have thought that developer coding was the main thing that you could do, but in fact there are many other options. You can start at the business end. You can be a business analyst and try and understand what the software systems that are needed are. Quality assurance is a very big role nowadays. Just being able to deliver to the customer as well. So that's a whole job in itself, making delivery pipelines. We now use techniques called continuous delivery, where a person can implement a new feature for a software system, and that same day it goes out to the customers and they are using it the very same day that it's been delivered and quality checked and passed through. So we've got now very tight timescales, and setting up the infrastructure for that can be a whole career. So I'm kind of running up to the end of my time now. I don't want to eat into Joanna's time for talking, but if you want to ask about any of these particular careers, feel free, and I can go into more detail at the end. Just to finish my part with a list of some of the companies that our students go on to work for. Of course, all the big tech companies you'd expect, IBM, Microsoft, Apple, but also the big banks. We send a lot of people to banks, but media also, and into government, and some many of our students will go out to form their own startups or to work in startups that are just growing around Manchester. And to give our students the startup experience, we actually run our own student software company within the department. You can go to the link there and see a little bit more about it, where teams of students are paid to work with us to deliver software to clients. So it gives a startup experience in the safety of the university environment. Okay, I'm going to hand over to Joanna now. Hopefully your slides are all there. Joanna, if you want to give me a wave when you want me to change slides, and I'll do that.
Okay,
over to you.
Fine. Okay, thank you, Suzanne. So hi, as you know, my name is Joanna, and I recognize that majority of you are now at an age where they have to make an important decision, which is which area do you want to specialize. And that sounds like an intimidating decision to me, because and I've been through that as well, because it will probably influence the next 10, 20 years of your life. And I cannot make that decision for you. It has to be something that comes only from yourself. You have to figure out what will make you happier in the longer term. But what I can do is explain how I made my own decision and how that turned out for me so far. So okay, can you go next?
Next one again. Next one.
Okay. So how I figured out that I wanted computer science? Well, I wasn't sure until like year 11, and then I went to this summer camp that was supposed to like make us to motivate us to follow a physics career. But it turned out the other way for them, because they gave me a project that involved more computer science than physics. And looking back at it, the programming part is the part that I was actually enjoying doing the most. So that gave me some of a clue of that I wanted to follow computer science. But that's not the main reason why I chose it. The main reason is because I've always had a problem choosing my favorite subject. I've always really liked biology. I really like evolution theories and stuff like that. I always really liked geology and volcans and rocks and how they form. And I like chemistry and physics, and math always been a really big part of my life as well. So making this decision would mean for me that, for example, if I chose biology, I could never like see physics again, or chemistry again, or all of the other subjects that I wanted again. So I chose computer science because while I was doing my degree, I would be in touch with math, which has always been like my second favorite, I guess. I would do it because you always need a bit of linear algebra, but it's not too much, to be fair. And by the end of my degree, I could actually go work in any of the areas that I also was interested in. I could go to, if I became interested in business, I could go to a bank as a business analyst. If I became interested, if I wanted to study in biology, I could actually go apply some machine learning models in NHS, because I've seen some job advertisements for that as well. So yes, it's I ended up choosing it because it ended up opening even more doors than it was closing, I guess. I don't even think that it was closing any doors in the end. So once I chose which course I wanted, then I had to choose an university. And if after a lot of lists of pros and cons, I ended up choosing the University of Manchester. And that's because when I was doing my research, I went to the course page, And I went through the modules because that's really important to see what you're going to learn. And there were things that really interested me. First, like the course promised to be really practical. Like there was this first year team project, and this was a really core reason for me to choose Manchester, is because when I looked at this module, I'm like, wow, in 1 year's time, I will actually be able to have a final product. I will actually have a physical evidence that I'm capable of doing something, you know? And that's like personally is really good, something physical to prove to the other people that I'm capable of doing something like that. And but from the other and from a career perspective, it's also really good to make to be assured that you will have something to put on your CV, because as a software developer, a big part of your CV will be projects you did on your own, and sometimes that feels like a pressure, like you have to do a project. In this case, no, you don't feel that pressure because you will have to do the project for the university anyway. And so that's one of the reasons. And then from the year 2, I would also have software engineering, where we are given like this giant code base, and we have to like deal with problems that like normal day-to-day software developers have to deal, like the testing that Suzanne was talking about, and migrating software, and stuff like that. So you would have like by the end of this course, you will actually understand, like you go to industry and you actually feel prepared. And yes, and then I've always had the battle inside me where like I never knew if I wanted the theory or if I wanted the practical side of stuff. And the fact that the University of Manchester also delivers the computer science and math module is also reassuring for me, because by the end of the first year, if I actually regretted going to the practical side, I could always switch. And the course is quite flexible in that sense, to be fair. And then there's also the industrial experience, which I wasn't planning to take in the beginning, but but it's good to make sure that there's always options. And then I've always liked the city. I really like the spirit, the free spirit, the activism that you breathe when you're in Manchester. And I come from a small city, so Manchester is pretty massive for me, but it's not as massive as London. So and being in a city that you identify yourself with, it's also really important. Yes, so well, those were my expectations before coming university. They came with what I was searching on course pages and on student forums and stuff like that. But then coming to university was different. And it's what I have to say is that it didn't let me down. Just on first year, I listed all the technologies that I was in touch only in my first year, and it's quite a big list, honestly. It's quite impressive to be able to learn so much so fast. And also the one thing that I really find really impressive about the course and the department itself is the amount of opportunities you get to connect with the employers in the industry. Like I think at least once a month you will have an opportunity to connect with employers and recruiters and graduates and stuff like that. And because like the university itself has a big career fair, and then the department itself has a career fair just with the software developing the software advertising software developer jobs from companies. And I'm really keen on the career fair that the department delivers, because it's smaller, the companies are relevant, and it really feels more cozy. Like it doesn't the formality, it's not as big as great as in the bigger career fairs organized by the university in general. And also there's these things called hackathons, which are the programming competitions, and they usually have sponsors that help them come through. And they're also really good places for you to connect with employers. Like and also the formality, while like usually these employers are there, and you can actually go for them and ask them a question to help you with the project that you are building in that hackathon. So like yes, sometimes it really feels like you're just taking a cup of coffee with them, which is great, because then you can hear about their own insights about the companies as they are speaking. Yeah, but like about their own experience of the company, and that's important to know how the company feels like. And yes, and then there's the software engineering one, which has a mentored partnership with some local companies from Manchester. In fact, that kind of was one of the reasons why I ended up working at ARM, because on the day that they took us to the offices, I ended up giving my CV to the manager, and 1 week later he actually called me. So yes, all these things, they're from a employability point of view, the university really does its job. And more importantly, so yes, so come to university, I come expecting a course, and in the end I'm delivered so much more than that. I'm delivered like an actual community. I feel I really fit in, because it's the majority of you think about computer science and all they think is oh, these really shy people, these really antisocial people. And no, it's really, I think, the opposite of that, because we have to be sociable people. Otherwise, I think there's no way we can survive in our own field, because multiple times we have to work in a team. And in general, even like to do the course, you understand that collaborating is key for you to be on top of everything, and for you to be on top of your work. And you end up meeting people from all sorts of backgrounds and places, which for me was like in the beginning kind of a culture shock, because Portugal is not exactly the most diverse country ever. But that, like, now is something I can't even, like, I can't come back, because I will miss all the sorts of people that I meet here. And no, we're not always talking about programming. We talk about all kind of stuff, because there's only so long you can talk about programming as well. And we have this computer science society, actually, which organizes organizes technical talks, technical events, but it also organizes like big socials like hackathons, which are a mix of both, and the Mayball. And usually these socials they actually sell out in so few time. I was part of the organization of the Mayball last year, and it sold out like in minutes, the last batch. So everyone, as you see, everyone actually wants to socialize as well. And having this community is really important, because the course is something you come to university to do a course, and it's something that you want to achieve in order to have some security for your future. But like, in order for you to look forward to that future that you are building, I think these memories and these friendships are really important, because they are the ones that actually make you really keen on keep going and looking forward to tomorrow. And yes, so it's really important, I think. And yes, so, and last year, I was looking for a summer internship, and I ended up going. I had the offers from more places, but I ended up going with ARM, because I had first, it's a technical company. I could have gone to a bank, but I prefer the more technical, a more technical perspective of the job. Not gonna lie, and um, oh, yes, and it's also in Manchester, which I already had accommodation here, so that's convenient. And oh yes, and I said I was going on a summer internship, yes, but around July, I actually decided that I wanted to. I asked the company to extend my contract for 9 months, and they did. And what do you know? I ended up here working for the full time. And I think also a good thing is that the university actually allowed it. I sent an email. I just had to send an email to like a couple of people, fill a form, and they allowed me to switch from a computer science degree to a computer science with industrial experience degree, which again shows the flexibility that you're allowed. And it's good. Not a lot of bureaucracy going on, really. And what do I actually do? Like, on my first, every 3 months, I work on a new team, on something new. On my first rotation, I was working with advanced product development team, which is a very outside the box team. Honestly, I've shared my experience with a lot of people with my friends, and like they're all very they all find it very strange and very different experience from what I've had. And basically, I was working with niche cybersecurity, which are called fault injection attacks, which basically are like you're simulating the effect of pointing a laser at some part in the hardware, and um, you show you check the effects that it had. And sometimes when you do this, it actually overrides the current machine instruction that that the computer is executing. And what this means is that sometimes I would actually bypass security checked cards without having the pin in the first place. So yeah, it's very interesting stuff. And on my second rotation, I was working with the high performance computing team, which is very big team, and I'm working on the math library one, where basically I need to migrate functions from one framework to another, and I need to optimize those functions. And I really like this the last 3 months that I've been on this team, because I get to learn some math on the side, and as I mentioned, I really like it. So it's really enjoyable. So how do I feel overall about this experience? I feel great. I have to work 8 hours, and those 8 hours I have to. It's all about problem solving, so it doesn't really feel like an obligation to me, and I get to learn. My free time actually means free time, and the reason why I'm saying this so boldly, it's because as a student, like being a student is, I guess, um, I know that the free time is never really free, because you always have to look for the deadlines, you always have coursework, you always have exams. So like when you're actually having your free time, you're always on background process of your head is just but maybe I should start working on the next thing. So I'm actually like I started reading again, I started jogging again, and so yes, that's one of the things that I've been enjoying the most. And then there's always the financial independence that you get for the first time, and that's also really that also feels really good, because like your parents start looking in a different perspective from you. They actually start looking at you like a person that has their life together and that's on the right path. And that's actually, I think that even improved my confidence a bit since I started working. So yes, that's my experience so far, and thank you for listening.
Great, thank you, Joanna. We're going to swap over to Jez now, so I'll stop sharing my screen. And over to you, Jez.
Okay. That's working okay. I'm hoping everyone can see and hear me okay.
Yeah.
Yeah, good. Okay, so I'm just going to whiz through these slides because Joanna's fantastic talk actually covered a fair few things that I was going to mention. So just to give you a background to the department here, and here's our lovely Kilburn building here in Manchester with the sunny blue skies. We have a really rich history here of computer science and department, something we're incredibly proud of. And it's a department of firsts here in Manchester. It's the birthplace, we call it the birthplace of modern computer science, and the world's first stored program computer, the baby, was here in June 1948. We're also the first institution to offer a computer science degree. I think the first cohort of students was around about 10, and we now welcome nearly 300 students. I think it's actually even going over 300 these days. But we're not all just about history. We remain pioneers in computer science, and in fact awarded the best environment in the UK for CS research. And you might think, well, why does research affect what I do as an undergraduate? But really it is so important that our academic staff are leaders in research, because they are the staff that you'd be learning from throughout your degree. Just to give you a bit of an overview about how a degree programme is structured, there are lots of sort of flexible options, as Joanna mentioned before, but in the first year you'd be covering really solid core fundamentals of computer science to give you that background and fundamental knowledge to then explore more specialised modules in your second year. You also do a software engineering team project. Suzanne is obviously a leader on that course. In year 3, as Joanna's done, you've got the option to then take an industrial experience programme. I'll talk a little bit more about that just a bit further down the line in this presentation. And then students would either come back from their industrial experience and do their final year. They'll then do an individual project, and you'll be paired with a supervisor who's an expert in the field that you've chosen. And then there is an optional year for an MEng year where you start to really delve into advanced topics, and that's into year 4 or year 5, depending if you've done that industrial experience year. As Joanna says, it's very flexible to kind of switch between these different courses and options. All you would need to do is give us enough time and talk to your personal tutor and our student support office, and we can normally switch you between these courses. How we teach? Well, we've really reinvented the programme in recent times to a more blended learning experience. This includes online lectures, there's practical labs, example classes, quizzes to help continue your learning, small group tutorials. So as Joanna said, you'll be working in teams a lot of the time doing project work, and you'll be meeting regularly with your academic supervisor. We also have guest lectures from industry. So this may be former students coming back, recent graduates, or just people from industry giving that insight into what their experience is like is working in the professional world. You'll see Steve here is, he's got a quote, "Students should leave here bursting with enthusiasm for the subject and really transforming the world over the coming decades." And Steve himself is a pioneer in computer science, as Suzanne will well know. He, in fact, was one of the budding computer scientists that came up with the technology for the chips that you would find in your mobile phones. In year 1, like I said, there are fundamentals of computer science. I won't go through them all, you can sort of see them there, but it really is giving you the background and platform to then delve into any of those areas and specialise into any of those areas. You'll do a year 1 team project, like I said, and in that team project, you'll create a website, an application of your choice. And you also get other skills like poster showcases and presentations, which you need those skills to progress in your career. So you can see in year 2, there's a lot more optional credits and modules available. And at this point, this is because you're grounded in all those kind of fundamentals, you can then switch on to any of these specializations. So even if you hadn't picked the artificial intelligence or the software engineering specialization, you could switch at this point and you'll start theming your degree with software engineering course units. All these course units are available on our website, and you can really delve into the details, see how they're assessed, see how they're taught, and read it and suggested reading lists as well. So the industrial experience here. This is a picture of Media City, which is just outside Manchester. And there's a lot of tech companies here. Manchester is in fact the second largest technological hub in the UK, only behind London. So really, really exciting place to work, and a lot of companies are moving here. So you don't necessarily have to travel outside of Manchester, but a lot of students do. They often go down to London, but there are opportunities here as well. Like Joanna was saying, that's quite of a benefit really if you've got accommodation sorted already. So industrial experience years normally last about 9 to 12 months, and you're paid a full salary, which is great for students. Around about 100 students go out each year, but I think that will increase with each year that the department progresses. And they could be large or small companies, you know, they can be big corporations, banks and places like Google and Disney+, or they can be small startup companies. So you can maybe have a bigger impact and feel like you're making more of a presence in one of these smaller companies. And we also, on site in the department, we're very proud of our dedicated employability team that helps support students find these placements and also keep in touch with them during the year, both with their employers and themselves, to see they're getting the best out of their experience. And finally, why do it? Well, 96% of the graduates from this degree who take this option are in a professional managerial job, because after this year in industry, you often come back with a job offer for that company. So really, really something beneficial that students should really seriously consider doing. And here you can see, like, here's some examples of why industrial experience really does fuel your career. Here's Teo, who works at Google. She was also on the Tech Makers, Women in Tech Makers scholarship there. She's now working full-time in London. And Joshua worked at CERN, which is home to the Large Hadron Collider, the world's biggest physics experiment. He's now doing a joint PhD with CERN with the University of Manchester, and he lives in the wonderful city of Geneva. I'd like to go out there and visit him one time. Both of these are actually on our podcast if you wanted to listen to more in-depth interviews with them. So moving to your final year, I mentioned before about the final year project. This is really your opportunity to work on a project with a supervisor and the expert in their field on something that you really want to get your teeth into. And there's opportunities to win some prizes. We can sort of see the variety of the projects just below there. And also this might launch you into kind of a career into further study. So students can actually go onto our master's courses or even onto our PhD courses. And it might be that your supervisor says, you're doing some fantastic research here. Have you thought about exploring this deeper into a PhD? So there's lots of options for students as they go through the degree here. Quickly, we've got a hardware library on site where you can use projects and which you can use for projects, and you can see some of the kit here that students are playing with. I'll quickly flick through the student kind of side of things because Joanna touched on that so nicely, but it's such a large, diverse student contingent here, including many international students. And I think there's over 60 nationalities in the department at the moment. And Joanna talked about free hackathons, but these are really, really valuable experiences for students to get involved in. It all ends with a lovely cap and gown procession in the huge great hall, which is rich in history at the university. You can see a popular picture here. This is some of our students, I think, in 2019, throwing their hats into the air. It really is a celebration with lots of family and friends joining us. And again, you can listen to some of our students from a previous graduation there. Again, we've seen this before, the kind of companies that students go to. Suzanne touched upon that. You really see a variety of places there, and there's so many doors open to you as a computer scientist. Quickly, some entry requirements for Malaysian students. It might not be that this matches up with what you exactly do at the moment, but don't worry about that. If you want to inquire about our courses, just go to our website and email our friendly admissions team, and they can talk through with you whether you meet or not, what our entry requirements are, and we can and tell you what your options are, potential options. So I won't dwell on this slide, but if you are interested, then please just contact us. And I think that was my last one, Joseph. Oh, there we go. Yeah, okay. So if you...
Well, look, thank you all three of you. It was really very comprehensive and obviously came from lots of different angles as well to answer them. And we'll see how it goes. So just as you're still there, just to stick on a couple of those things. And just in terms of the entry requirements, obviously we had this a lot yesterday in terms of A-levels. Usually we're looking at mathematics, aren't we, as a kind of more mandatory A-level to be taken if we're going on to a computer science type course. Is that the same for Manchester?
Yeah, absolutely. You hit the nail on the head there. Yeah, maths is the really key essential requirement for students. There are other favourable subjects that we look at, including computer science and sciences as well, but maths is really the essential one, because I think Suzanne will agree, although it is a computer science course, a lot of the fundamentals are around mathematical programming. So
Yes.
yeah, it really is a key requirement.
There's also our HCI program, which has slightly less strict mathematical requirements and builds more on things like psychology and subjects like that. So there's slight variance, but mainly maths is so key. We need it.
Yeah,
Yeah,
there is one route there for students who haven't taken the maths to still take a computer science degree, but they need to be aware of what it covers. So we would recommend students to really look at the modules there, because it is a split between sort of two different subject areas.
Okay. Yeah, our speaker yesterday from Sussex was very free and easy. He said you could actually go on without maths, although he obviously did emphasise the fact that clearly that was the most commonly used skill within their course too, as we did cover yesterday. A lot of courses Manchester included would require it and have it as a mandatory thing. Again, we've got a question come through on the chat for us. I suppose, Suzanne, you're probably, perhaps Joanna as well, maybe best for this, but what do you think of students' past experience in terms of coding particularly? You know, how important is that? Or is it the other way around? Is it detrimental because you find you have to reteach them? What's your thoughts about students coming with coding experience?
So maybe I'll answer from the official department position, and Joanna can say from her experience. We get the whole range of people. We get some people who've been running their own company and know more about it than I do. And we get some people who've never coded, or they've made a few web pages or things like that. We try in our first year to bring everybody up to the same standard. So the first year is a challenge because we've got such different range of skills, but we definitely want to have people who don't have much coding experience. If you've got the raw ability, you just haven't had the chance to apply it yet, come and learn how to do it. And in some ways, for me personally as a teacher, I kind of prefer that, because people haven't learned bad habits that we have to then try and get away from. So I kind of like it when someone with a great coding brain but not much coding experience comes to us, because that's as a teaching experience, that's perfect for us. But
we get that quite
challenge.
Often with professional pathways. People say that we have it quite a lot of law lecturers that will say law. We don't run a law A level, but people that do law A level sometimes have to be untaught some of the things they've learned before it really does. So it sounds like occasionally that happens with you as well. So
yes, I think because coding is something people do in their own time, and they're often self-taught. So even, you know, people might be being taught exactly the right things on their courses, but in their own time, I mean, it's great to do that. It's great to code in your own time and work on team projects and things, but you can pick up really bad habits that way. Joanna, do you want to add anything to that?
Yeah, to be fair, I'm one of those cases. Like my programming experience was minimal. Like, I don't know if you know this tool called Scratch. That's pretty much all I knew. And one thing as well that I want to make sure is that, like, just because you have less programming experience, it doesn't mean you will do worse than others in the course that have more programming experience. Because I think the course does a good job in trying to even out in very quick, like all the skills that there are. And like the kind of things that they're evaluating, they're things that usually people don't know. Like, they know the for loops, they know the while loops, but they don't really know the theory, the whole theory behind it. And I say, like, it's more important to have like the reasoning there rather than like the programming part, and then all the rest the course will teach you.
Okay, that's great advice. And obviously we do have an enthusiastic bunch of students. We do have ones that like to take on a lot of extracurricular stuff. And actually, Suzanne, I did just want to ask you a little bit, just because the first thing you mentioned was quality. So I guess when you're talking about students taking on extracurricular thing, is the advice is to maybe look at smaller projects where they can look at the quality and the finish of something, rather than taking on sort of larger strands of data or whatever it is that they're looking at. What would be your advice for that kind of extracurricular activity?
Yeah, it's challenging. I think any experience is good. So hackathons, for example, which are often talks about, are a great experience for students, but quality doesn't generally come into it in a hackathon. You're just trying to throw so much what you can together in a short amount of time. And I think it's good if you are doing hackathons and your own projects to try and balance that out. with the main thing I think is to try and have a real customer. So that really brings in the quality angle. Then if you're just building it for yourself, that's fine. But if you can build it for your family or for a friend's business or have any kind of real customer, that forces you to engage with the challenges of software engineering, not just, oh, I'm a bit stuck now, so I just won't add that feature. You know, you have to add the feature because that's what the customer needs. And the customer will say, I don't like that design. I don't understand how to use that. And then you have to rethink the user interface and things like that. So trying as much as possible to work with a real customer, even if it's a very small project, I think that's good. Coming back to your own code as well is a really useful experience. So writing code and then coming back to it 6 months or a year later, and you think, what is this? Why did I do this way? And coming back to that code and having to fix the mess you made is a really salutary experience in terms of understanding what's needed for code quality.
So did you do anything of that type, Joanna, before you started the course? Did you have much experience of that? Any kind of projects of that type?
I know. I think the only project, and I think I even mentioned that on my personal statement, was I made this triangle solver with Scratch again. So that's mostly it. And oh yes, I did. Like there's a similar one to Scratch called App Inventor, which is basically again blocking language, but then you can actually develop Android applications with it. And I did one that like it was to help me budget my money. This was a time when my father was mad at me and he started cutting on my allowance and I started needing it. So yeah,
That's
honestly,
quite an important development.
Yeah. Honestly, I think it also like shows how computer science kind of feels. Like it's like you need something, so you just do it. And that's I think having that spirit is bigger than the final product you end up with.
Okay. Can I ask you? You mentioned your personal statement there. It does come up sometimes. We've got a lot of students here looking to maybe apply at the moment or next year. Can you remember much about your personal statement, Joanna? Can you remember what you put in it, what you wrote about?
To be fair, I don't remember much right now.
Too long ago.
Yes, I remember that I followed. I remember once I did my personal statement, I went to the university website to check what they were looking for in a personal statement, and after that, I actually was like checking everything if I was mentioning everything, and that actually turned out really well. Like so, when you're doing a personal statement, really go through what universities are looking for and really trust that they're looking for that, and don't forget to mention the key points.
Yeah, just on the personal, just on the personal statement, just don't be too apprehensive about it or really worry about it. It's just your opportunity to show sort of clear motivation for academic study and put across your enthusiasm for the subject area, discipline area that you're choosing to study as well. And we want to hear more about you know, your general interests and hobbies and any kind of experience that you're doing in your extracurricular activities. So don't get hung up, is our advice on your personal statement. It's not, it really isn't going to be a massive deal breaker for universities, but they are really useful things for our admissions teams and admissions tutors to sort of get to know a little bit more about you and your personal journey.
Yeah, that's really good advice. I'd just say, obviously, for our students, we've applied to different types of institutions. We know some look at it more keenly than others and look at it in different ways. And that's one of the things in the department that we do. We have a look at the 5 universities you're applying to and try and find the best personal statement that's going to fit with those 5 institutions that you're applying to the UK.
Absolutely. Yeah, you do need to consider that. Yeah.
Jez, I just wanted to follow up with just something very quickly on you. This is something very particular for Manchester, actually. And I know I've spoken to people in your sort of broader engineering department before. And I did mention earlier that you are a very big university, the biggest single university. I know your engineering department are very good at swapping people between pathways. So if you go on to mechanical engineering, it's very easy in the second year to move on to one of the other pathways. Is that that seemed to be what you were sort of saying as well? I think that's obviously one of the things people worry about is going down a particular avenue that they then can't get out of. I think there's quite a lot of flexibility at Manchester in terms of the options once you've started the course.
Yeah, certainly, and basically it'll be dealt on a case by case basis, and there'll be meetings with probably a personal tutor to make sure that you're making the right decision if you are requesting a transfer, and they'll want to also know the reasons why you want to do it, because it might be they're not enjoying their current course, but there might be reasons that could be resolved of why they're not enjoying their current course. So, and then there'll be sort of we would have to have a look at the kind of modules that you're doing, and also the entry requirements that you came in on, because there might be some variance on the course that you came into. If it was a mechanical engineering course, we'd have to have a look at what you came in on, because we wouldn't want you to switch onto a course where you would struggle with some of the content, and there would be academics teaching the course expecting you to be of a certain level, maybe in mathematics or some computer science modules. So yes, in theory, there is a lot of flexibility there, but no decision will be taken rashly, and we need to make sure that it's both the right move for those teaching the course and also for the student, most importantly the student, because we wouldn't want them to then transfer onto a course that they then find 6 months down the line they want to change again, which is not a good experience for anybody, really.
Okay, brilliant. Thank you very much for that. Well, I think we've hit the witching hour, which is 5 minutes to 6 Malaysia time. So we're going to stop there. Thank you very much. Obviously, we'll make this video available to everyone, as we always do with these videos. All your contact details will be available. So if you want to follow up with Jez, Suzanne, and potentially even Joanna as well, I'm not quite sure, then we'll be able to do that. And you'll be able to drop them any questions. And obviously, if anything comes up that you want to ask us, do that too. So I'd just like to say thank you very much to the three of you. Thank you for joining us tonight. It's been really, really great.
Thank you.
Thanks for the invitation.
Okay. No problem at all. And students, good evening. Thank you for joining us. See you again soon.
Bye, everyone.
Bye.
Bye-bye.